All right, Precalculus. We're going to start section 7.4 here on trigonometric identities. Traditionally, everybody hates this section, okay? Because it's like a puzzle. It's kind of like proofs in geometry, except you don't have to name the theorem that you used. You have to rewrite stuff, and you're not really sure where you're going. So take it slow. I'm going to try and break this down into several different ways that it can go. Here we go. Two functions are identically equal if f of x is equal to g of x for every value of x. Put in a 2, they're both equal. Put in a 5, they're both equal, for which both f of x and g of x are defined. Okay, such an equation is referred to as an identity. Now, if it involves a trig function in particular, we don't usually talk about identities very often unless it's to deal with trig functions. We refer to it as a trigonometric identity. And we are going to use trigonometric identities in many, many different ways over the next couple sections. Okay, we will verify trigonometric identities. We will simplify trigonometric identities, and we will establish trigonometric identities, mostly using substitution and some standard algebra tricks that you've learned and are really good at. But first, you need a list of the identities that we already know. The quotient identities are referred to, the tangent is equal to sine of x over cosine of x. Couldn't have said that worse if I tried. And then the cotangent of x is cosine of x over sine of x. Sorry, those are a little bunched up together. The cosecant, these are the reciprocal identities, is 1 over the sine of x. I think you already know that. Secant is 1 over cosine of x. And the cotangent can also, in addition to be written as cosine over sine, can be 1 over the tangent of x. Those are the quotient identities and the reciprocal identities. We will be using those to substitute. The Pythagorean identity goes like this. Sine squared x plus cosine squared x equals 1. Now, we already used that this chapter. I'm here to tell you there are two more Pythagorean identities. This is an algebraic equation. There's a equal sign, and you have an algebraic expression involving trigonometric ratios here, or functions. I'm going to divide everything by sine squared of x. If you divide sine squared by sine squared, you get 1. Then I'm going to put a plus. If you divide cosine squared by sine squared, cosine over sine is cotangent, but it's being squared, so this is cotangent squared x. And I'm going to put an equal sign, and if you divide 1 by sine, you get cosecant, so this is cosecant squared x. They all have to be squared because they come from the Pythagorean theorem of a squared plus b squared equals c squared. I'm going to do this one more time, but I'm going to take all these, and instead of dividing by sine squared of x, I'm going to divide by cosine squared. Sine squared divided by cosine squared would be tangent squared. Cosine squared divided by cosine squared would just be 1. And 1 divided by cosine squared would be secant squared. There are the three Pythagorean identities. Now, if I take up a Pythagorean identity and I isolate it for sine of x or cosine of x, this is what I get. Make sure you square those. If I take this original one and I want sine squared by itself, sine squared x is equal to, subtract cosine squared x, 1 minus cosine squared x. I do believe we went over this in the notes earlier this chapter. And if I want cosine squared of x by itself, I would subtract 1 minus sine squared. And there you go. This is a list of identities that we're going to use over and over. So keep this page handy as you're looking at the next couple pages of notes. We go to number 2. And I have 2 tricks for you guys in these notes. We'll do one trick today and another one tomorrow. Trick number 1, simplify trigonometric expressions. Okay, now look, I've got hints for you. Hint number 1, hint number 2, hint number 3. Here's the problem. This is what people don't like about trigonometric identities. You won't get a hint in your direction all the time. You'll just be given an expression and you'll be told to rewrite it, and you have to decide. You have to go through your head, hey, which of these tricks, these hints that Larson gave me, which one should I use? Hint number 1, helps a lot. It frequently helps to rewrite everything you can in terms of sine and cosine. Now, you guys, do not get lazy and stop writing the angle. Whether I put an x or a theta or a w, whatever I put there, make sure and write it every time. I don't want to see just you guys just writing sine and cosine. A trig function is sine of an angle. Okay, if I write this in terms of sine and cosine, sorry, I'm yawning. How can I rewrite cotangent? Well, I could write it as 1 over tangent, but that's not sine and cosine. Cotangent is cosine over sine. So I'm going to write this top as the cosine of theta over the sine of theta. And in the bottom, I have cosecant. And cosecant, if you check your identities, is 1 over sine. So I'm going to write this as 1 over the sine of theta. Now, my better pre-calculus students are going to recognize that those signs cancel. But some of you aren't going to see that. And so how do you divide by a fraction? You multiply by the reciprocal. So instead of 1 over sine, this will be sine over 1. And now everybody sees that the signs cancel. And this simplifies just simply to the cosine of theta. That was hint number 1. Rewrite as much as you can as sine and cosine, and then just see what cancels or disappears. This one will be quite a bit more complicated. I've got an equal sign here. Instead of just simplifying, I'm going to show that the following is true. I'm going to rewrite one of these until it looks like the other one. This trick is going to be multiplied by the conjugate. So changing everything to sine and cosine, that's one trick. Here's another trick. Multiply by the conjugate. Look, I see this 1 minus sign, or 1 plus sign. I'm going to multiply top and bottom by 1 minus sign, because something good's going to happen. I'm not going to touch the right side of this. I'm going to change this left side until it looks like that. Don't change both sides. Other math teachers tell you that's okay. I'm going to tell you every time, I don't want you to change one of these sides. Leave this one as it is and change this. We could, on this side, multiply by 1 plus sine of x, and we would end up getting the same place. But we're going to change both sides. We're going to change one side at a time. So if I multiply this by 1 minus sine, this cosine will get distributed. And it will become cosine of x minus sine of x times cosine of x. That's in my numerator. In the bottom, what happens is I have 1 times 1 is 1. 1 times plus sine of x is plus the sine of x. And then watch this. Negative sine of x times 1 is minus the sine of x, so that they cancel. And then I get minus sine squared x. Okay, and that's equal to 1 minus the sine of x over cosine of x. Now guys, on the left side, that plus and that minus cancel, and this is just 1 minus sine squared x. And I'm going to tell you I made a mistake distributing on the top, but I know that from experience. I wouldn't expect you guys to know that. Here's your job now. Recognize what's going on the left side of the equal sign. I keep writing this so I can take a peek and see, hey, what's this supposed to end up looking like? I'm going to change this 1 minus sine squared. Look, over here, I'm going to go to my identities. 1 minus sine squared is on here. It's right there. 1 minus sine squared can be replaced with cosine squared anywhere I see it. This is true for all angles where x is defined. So if I see 1 minus sine squared, I can rewrite it as cosine squared. I'm going to rewrite this denominator. Here we go. Cosine squared x. And so on the top, I am going to factor that cosine back out because I'm now seeing that I need it by itself. Okay, that's what we had all the way up here. 1 minus sine times cosine. I should not have distributed that. So it's supposed to be equal to 1 minus sine of x over cosine of x. Now, I'm not going to move on to my next step. I'm just going to make room there. You guys should see what happens here. I have this times this whole grouping symbol divided by cosine squared. What would you do if I had x over x squared and asked you to simplify? You would say that x's cancel and it ends up being 1 over x. This cosine cancels with one of these cosines. And so the cosine is gone, and I have 1 minus sine of x in the numerator. One of these, cosine squared means cosine of x times cosine of x, doesn't it? I mean, that's what it means. Cosine squared. So that one cancels with one of them, and I have one of them left. And look what the right side of the equal sign says. It's the exact same thing. Check. I did show that this is true because I changed one side until it is exactly equal to the other side. All right. Hint number 3 is going to go like this. There's no equal sign. These are two fractions, and I'm simplifying. Yep. Turn two fractions into one fraction by getting a common denominator. You ready for this? If you have two terms and neither one is a factor of the other one, you multiply to get a common denominator of the product of these things. I'm going to multiply this fraction by sine of u over the sine of u. I'm going to multiply this fraction by cosine of u over the cosine of u so that they will both have the same denominator. I'll write them in the same order too. I'm going to go sine of u times the cosine of u on the bottom for this one. And up the top, I'm not going to multiply anything. I fell for that once. We're going to leave this and see if we notice anything canceling. And then here on the bottom, I'll go in the same order. I want sine of u on the bottom and then cosine of u. That's these two multiplied together. And then what happens here? I've got cotangent of u minus cosine of u, and it's all times the sine of u. Okay? What is going on here? So I'm going to write one denominator of sine of u cosine of u. Now, I don't see this canceling with all of this stuff, so I'm actually going to use the distributive property and write all of this stuff together. Ready? Cosine times both of these goes cosine of u plus cosine of u times the sine of u. Okay, that's these two. Then here, the sine of u will get multiplied by both of these. So this goes sine of u times the cotangent of u minus the sine of u times the cosine of u. Okay, so let's see if we notice anything. That's cosine times sine. That's also cosine times sine. These actually cancel. That's like 4 minus 4, right? And so now I have the cosine of u plus the sine of u cotangent of u is over the sine of u cosine of u. Those don't cancel because of this plus. Don't fall for that. Do not fall for that. However, I've got this cotangent here and this sine right here. Cotangent can be rewritten. Cotangent can be written as cosine over sine. Cotangent can always be written as cosine over sine. So look, I'm going to go over here. I'm going to go cosine of u plus, it's the sine of u times cosine of u over the sine of u. That's all in the numerator over sine of u cosine of u. And look, these signs cancel, guys. This is over 1. These signs actually cancel. I have cosine of u plus cosine of u. So let's go up here. Cosine of u plus the cosine of u. I can write that as 2 cosine of u. And this is sine of u times the cosine of u. So again, that can't cancel yet. Okay, so I have 2 cosine of u on the top, and on the bottom I have sine of u times the cosine of u. Oh, look at that. Cosine and cosine. Now there's no plus or minus in here. That actually does cancel. This is 2 over the sine of u. I could leave it like that, or isn't 1 over sine, can I write 1 over sine somehow? 1 over sine, that's cosecant. I could write this as 2 times the cosecant of u. All of this mess I started with, it took a lot of work, guys. But you get common denominators, you put them together as one fraction, see what cancels, and then just keep simplifying and canceling until you're all the way simplified. Let's go to the next page.